So we've got a particle now moving and we've been given its velocity, and you can see that the velocity is time dependent. So the velocity is constantly varying as the value of t varies. And as you can see, t is clocking up from 0. And in part A, we've been asked to find the speed, that's an important word, at time t equals 0. So here is the speed. So now I sub t equals 0. So these two terms knock out, so I just get that v is equal to 7i plus, I was a bit quick with my plus because this term knocks out, so we're just left with negative 3j. But that's not the speed, that's the velocity. So the speed is equal to the square root of 7 squared plus 3 squared, and we can ignore the negative signs, and this turns out to be the square root of 58 meters per second. So in part B, we've been asked to find the value of t when p is moving parallel to I plus j. So if this is moving parallel to I plus j, you notice here the components of I and j are equal. So if I equate the components of I and j, I can solve for t, and that will answer part B and give us the time. And there I've written it out. Simplifying that down, I get that t squared plus 3t minus 10 is equal to 0, and that factorizes quite easily to t minus 2 and t plus 5. This will give two answers, that t is equal to 2 or t is equal to negative 5. And as we're told t must be greater than 0 up here, I can reject these two answers, which leaves the correct answer that t is equal to 2. So in part C, the fun starts because they're asking us to find the acceleration equation from the velocity equation. Now, the acceleration is the rate of change of velocity. So if I differentiate this with respect to t, I will get the acceleration. So a is equal to dv dt, which is equal to, let's do each term separately. I get 2t minus 3, and that's the I component of the acceleration, plus differentiating this 4t, and that's the j component. And that's all they want for part C. In a similar way of part B, they now want us to find the value of t when the direction of the acceleration is perpendicular to I. Well, for the direction to be perpendicular to I, our motion must only be along the j-axis, which means that the I component of the acceleration will be 0. So if I put that down as an equation, I can solve for t when this happens. So I get that 2t minus 3 is equal to 0, and therefore t is equal to 3/2 seconds. And that's the answer.